Okay, so this update from Kling might change how creators make videos. They just updated their motion capture model, and it's kind of wild what it can do. Because now you don't need costumes, you don't need makeup, you don't even need to look like the character. And it's all gotten so much easier. And we already know how big of a deal their motion control feature was on their last version. People have been using it to make all kinds of viral dance videos where they swap themselves into scenes, make dogs dance, all kinds of crazy stuff. But even more interesting to me is that people have been using it to capture real acting and nuanced facial movements and transfer that performance onto whatever character they want. So when this update dropped, I wanted to dive in and see if Motion Control 3.0 is actually a meaningful upgrade or if it's basically the same tool in a new version number. But more importantly, I wanted to see if this update could become a bigger part of my AI filmmaking workflow. So in this video, I want to break down a few things. First, what actually changed in Motion Control 3.0. Second, how to use it step by step. And third, the strengths and weaknesses that might determine whether this tool actually fits into a real AI filmmaking workflow. And later in this video, I'll show you a series of real examples that I generated so you can actually see what worked, what broke, and where this tool really starts to shine. And if you're new here, I'm Khalil from AI for Real Life. I've been deep in the AI image and video space for the past few years, testing tools, breaking workflows, and figuring out what actually holds up when you try to use these models inside of real creative projects. And this channel is where I take you behind the scenes of my projects, testing different tools and seeing what actually works for client projects, personal projects, and the broader AI filmmaking space. All right, so let's dive in and see how this update actually holds up. All right, so Kling Motion Control. What actually is Kling Motion Control? So Kling Motion Control, it basically lets you take a performance from a video and then transfer that motion onto a character, pretty much whatever character you want. And Kling maps your body motion onto whatever character or image you upload. And this type of motion capture technology, it's not brand new technology. And since the first versions of this tool, people have been using them for viral dance videos, memes, and all kinds of social media clips, which is actually pretty impressive, pretty funny. But when I first saw this update, my thought was on something different. Could it actually work for detailed dialogue scenes and for real AI filmmaking? And that was the main thing that I wanted to test here. Because if you could reliably transfer subtle performances, then it could really become a useful tool for building out actual cinematic scenes. So with this in mind, the first thing I wanted to understand was what actually changed in Kling Motion Control 3.0 versus the 2.6 model. So according to Kling, the 3.0 model improves a few important things. Let's look at them. First thing that they mention is that facial identity is supposed to hold together much better than it used to when the head turns or moves. Let's see. Second, the motion capture itself should be more accurate. It's an updated model. That makes sense. And third, you can now bind character elements so that Kling has more reference information about the character from different angles. Now that one's actually pretty big. We'll talk about that a little later on. So on paper, these are pretty meaningful upgrades. But the real question is whether these things actually hold up once you start pushing the model. Because on paper, a lot of things look really good, right? So later in the video, we're going to stress test all of these and see how well they actually perform. But before we get into those tests, let me quickly show you how the setup actually works. So inside of Kling, you go to the generate section and then you select motion control. And the first thing you want to do is make sure that you're using the video 3.0 model instead of the older 2.6 version. And then after that, you just upload a reference video. Now, there are some limitations for the whole reference video. So if the character orientation is set to match the video, which is one of the settings here, the maximum duration of the reference clip is 30 seconds. And this mode, from what I understand, works best for complex body movement and acting accuracy because the character strictly follows the motion of your performance. And I'll explain that a little bit more later on. And if the character orientation is set to match the image, then the maximum duration is 10 seconds for this one. And this mode is more focused on maintaining the framing and composition of the reference image and supporting camera movements. And I'll dive a little deeper into that because that confused me a bit for a while, actually up until today. So I'll dive into that a little bit deeper later on. And your clip also needs to be at least 3 seconds of continuous action for the model to generate a result. And for your uploads, the maximum size is 100 megabytes. So after you have your reference video loaded up, step 2 is uploading your character image. And this can be an AI character or a real person. Or from what we've seen all over the internet, it could be dogs and babies and all kinds of stuff too. And with earlier versions, it was actually really helpful if the framing of the image matched the reference video pretty closely. We did a lot of testing with that, and that really helped out a lot. But with this 3.0 model, it seems to be a little bit more forgiving, but it still helps if the compositions are similar. So next you choose the character orientation setting. And you can have the character orientation match the video or match the image like I mentioned a little bit earlier. And I tested both and the results, they were pretty different, but it was a kind of strange test. And I'll talk about that a little bit later on. But then you also have the option to bind a character element. And that's the one that is a big update. That is something that they changed in there. So if you have a character built out as an element inside of Kling, binding that helps maintain consistency because the system has more data about the character from different angles. And if you want to know more about building out your elements, check out my previous video that I did about Kling 3.0, especially the Omni model, because I go over all of that. So down below here, you'll see a prompt box where you can add things like background motion or environment details. You're obviously not prompting for the motion of the character because that's what the video is there for, right? And finally, you choose a resolution and whether you want it to keep the audio from the original clip or not. So obviously, if you're doing dialogue, you're gonna need to keep the audio. And that's the basic setup. So once I had that workflow dialed in, which is very similar to the previous workflow, minus the elements feature, I started running a few tests to see where things held together and where they started to break, which is the whole reason for doing this, right? So the first thing I tested was the orientation setting. And honestly, the setting has confused me ever since the very first version of motion control came out. So before running the test, I actually looked it up just to understand exactly how it's supposed to work. So the easiest way to think about it is this. If a character orientation matches the video, the actual actor is the boss. And that means that the reference video controls everything. So however the person in the video turns or moves or angles the body, the generated character will follow that motion exactly, or that's the plan at least. But if the character orientation matches the image is the boss. So if your character image is turned slightly sideways or looking in a certain direction, the model will try to keep that orientation even if the performance in the reference video is the person or whatever facing straight towards the camera. But the key word here is try because it doesn't always perfectly maintain that angle. So with this in mind, I ran the same setup twice. One where the character orientation matched the video and one where it matched the image. And the version where the orientation matched the video held up much better. The motion looked more natural and the facial movement stayed more consistent. And when I switched it to match the image, things started to fall apart. But this also wasn't a very standardized test. I had the camera moving everywhere and I was like sitting up and it was all over the place. So it might not be the best test. Do a little more testing on your own with that. But that's what I got with this, I guess, non-standardized test. So with this orientation test, I used a lot of motion on purpose. I really wanted to see what would happen if I did all those things. I was turning, I was moving my body, I was lifting the camera, I was doing all these exaggerated movements. So it'd be obvious how the orientation settings affected the results, even if they weren't exactly accurate to why those orientation settings were there. I just tried it anyways. But for a later test, I was covering my face and turning my head completely with the camera where it was actually static, and I'll show you that here in a bit. So with this, I just wanted to see how the model handled things like head turns and when your face is covered for a second, but the shot is actually stable. I just wanted to see how it reacted with these different elements. And honestly, with Motion Control 3.0, it actually recovered pretty well. For the character, the identity stayed relatively consistent even after the face was partially covered. Like, it stayed really consistent. But it's not perfect though. And one thing that I noticed that I do a lot is not very good for this model is I'll lick my lips, right? And if you do something like that, for whatever reason, that'll throw off the model a lot of times. We learned that in the past. It still looks like it might be the same with this one. So I definitely avoid licking your lips as you're doing your acting. But overall, it really held together better than I expected once the shot stayed stable and the model only had to deal with head movement and when the face was covered. But next I wanted to test it in an actual cinematic situation. So for this test, I recreated a small moment from the life of the Lazy Mon story that I'm building out here in the background weekly when I'm not doing client work. And in this scene, I'm already laughing. So this scene takes place in the airport customs line on the very first trip down to Costa Rica. Now, when you watch this clip, you'll also understand something important about this tool and other tools like this. The model is only as good as the acting that's driving it. And in this case, my acting was really bad. It shows you how bad of an actor and it gives you an appreciation for actual actors. So go ahead and check this out and you be the judge.
Pasaporte, porfa. Passport, please.
Oh, no, sí, es porque estás muy bonita.
Security.
All right, so the goal here was to see how the system handled a few specific things. So ignore the acting and focus on the technology here, all right? Please try. So we're talking about full head turns, when the face gets covered, and whether the character would drift over time. So when the character turned his head all together, the identity, it held together really well. When the face was partially blocked, it still recovered and kept the same character. And those were the things that they were saying that it did. It actually worked out. Now there were a few mouth glitches, but nothing too extreme. But also, like I said, I lick my lips a lot, so it is what it is. But from a cinematics perspective, this can definitely be useful in the right situations. All right, so everybody always asked about consistency with the voice, and with Kling 3.0 Omni, you can actually bind a voice to the character that's actually pretty good. It's not dead on every time. Sometimes it's louder, sometimes it's softer, sometimes it's slightly off. But I actually did a test where I had the character voice that I had made in ElevenLabs, and that's what was bound to the character. But then I also had some clips that I ran it through ElevenLabs voice changer using that same character voice setting. And going back and forth, it was actually really consistent, which was huge. I was like, okay, that actually held up a lot better than I thought it would. But with Kling 3.0 Motion Control, you can use a character as an element when you're doing these motion control things. So when I set up this new character with a bound voice, I wanted to see if the motion control would actually automatically replace the audio with that voice. And unfortunately, it didn't work that way. Right now, the system only maintains the original audio from the reference video or no audio at all. So if the character has a voice bound to it, motion control will not automatically swap out the dialogue in that voice. Now, I could be missing something here. I could be wrong about that. And if I am, please let me know in the comments. But based on my tests, it looks like you still have to replace the voice manually afterwards. Baby steps, right? So for this, I would use something like the voice changer in ElevenLabs to go ahead and swap the voice over. But if Kling ever adds the ability for motion control to automatically use the character's bound voice, it's going to be a huge update. Looking forward to that one. You hear me, Kling? But even with all this, it's really cool. Love it. The big question here is where it fits into a real AI filmmaking workflow. Because Kling Omni, it already does a lot. I'm really impressed with it. It's not perfect, and you're going to spend some money on it, but I do love it. See, when Omni lands the dialogue and acting, it's really amazing. But here's the thing. Sometimes it'll just completely refuse to land a certain word. I think for whatever reason, it decided not to say the word dirty for one day. It wouldn't say the word physical for another day. It wouldn't say the word peptides on a different day. And as many times as I generated, it was just not deciding to do it. And honestly, it's really frustrating because then you got to figure out a way to get around that. And with that, there are some ways to do it. You can use phonetic spellings and different things like that, but still sometimes with that, you're running generations and it's not great. So hopefully they fix that soon. But the point of that is that motion control actually gives you another option. So if it's not getting it right and it's not getting the acting right or not picking up a word, then you can perform the line yourself. You can upload the video, you put the character on top of it, and then you have the exact acting beat that you wanted. But the only thing is that you still need to change the voice. And that can get a little tricky with matching the voice from ElevenLabs with this, but it can work out with little tweaking. But even with that, this is where I see the biggest value. It's not exactly replacing normal generation, but supplementing it when the model refuses to cooperate. And this is where I think the hybrid approach is gonna really become powerful as these models get better. When you have actors with nuanced acting and styles and all these things that can transfer onto a video, onto any character without makeup, without wardrobe, with all these things, that can be a powerful tool. And it looks like the AI and the technology is actually getting there where it can be done pretty well. So what I envision, at least for a future workflow for me, is where I have an actor that's acting out the nuances and really bringing the performance to the table. But then for the supplementary shots and the filler shots and the in-between scenes, that can be handled with AI. So the combination of human performance and AI generation is where I personally think the future is headed. At least my future, hopefully. We'll see. So after running all these tests, the real question becomes, where this actually fits inside of an AI filmmaking workflow. Certain movements still break the model, like the licking of the lips. Nice, I probably said it too many times already, but background motion, it can also introduce artifacts. And the output, it really depends heavily on the quality of the performance driving it. That's a big thing, right? Which leads to the biggest limitation of it. The tool is only as good as the actor behind it. And if the acting is bad, like you saw before, it's not gonna work out. So unfortunately, for someone like me, it might actually be better to try to prompt the acting instead of actually performing it out myself. So after testing it, my final overall take is that Motion Control 3.0 is a solid tool. And the way that you use it really depends on your use case. If you have access to strong actors, or you want very nuanced performances, or even high motion single person scene where you're dancing or doing whatever, this tool can be extremely useful. But if you're not a great actor like myself, or you don't have access to one, then using motion control as more of a supporting tool might make more sense. So in other words, it's not a one-size-fits-all solution. But in the right situation, it can be a really powerful part of AI filmmaking workflows. So this is my take on Kling 3.0 motion control, and if you made it this far, please make sure to subscribe to the channel. It really helps me grow the channel and spend more time building out the projects that I share behind the scenes. And I also have a few guides available on some of the subjects that I cover on this channel. The links to those are in the description below. And I'm also currently working on some deeper courses and bigger projects to help us all level up together in the whole AI filmmaking space. So thank you for watching, and hopefully this upcoming week I'll have a little more time to dive back into my Chubby Checker trailer and the Life of the Lazy Mon project when I get done with some client work. So keep an eye out for those updates, and I'll catch you in the next one.